Hello, my name is Luke Gagne. I'm a senior mechanical engineering student at Western New England University.
My name is Thomas Kozak, and I am a senior mechanical engineering student at Western New England University.
And my name is Edward Nimchinsky, and I am also a senior mechanical engineering student at Western New England University. And our senior design project was to create an experimental setup for researching flow boiling and microchannels.
My primary responsibility was the fabrication of the experimental setup. Just a quick overview of the setup itself. Water starts in the stainless steel reservoir, and then it is drawn into the flow loop by the gear pump and driver. Water then enters the heat exchanger. The hot side of the heat exchanger is in its own loop with the thermal bath circulator you see here. After water leaves the heat exchanger, enters the test section. After the water exits the test section, any vapor is condensed back into a liquid and the water is recirculated into the loop.
My portion of the project was design and fabrication of the test section housing. This top plate here you can see is polycarbonate so that we could see into the channels while we're testing. The plate below is the main housing made of G7 fiberglass. This is for rigidity and heat retention. Below that is the aluminosilicate plate for insulation, so we keep heat flux moving up towards the microchannels. And under that is an aluminum plate for rigidity.
My primary responsibility was to design and fabricate the test section and test section heater, which is two separate parts, in order to be able to test out different types of test sections more easily. And featured in our first test section is 10 microchannels of hydraulic diameter with 500 micron, and this is the actual physical location where you have the phase change occur and the absorption of latent energy from the coolant. And both parts are made out of oxygen-free copper.